Recording in progress. Ooh. Are we going to start or? Okay. By the way, is this content going somewhere else besides Zoom? Is it on like YouTube or something like that? Because I would also like to see if I can, if I can get some questions from you and all that stuff while I present. So I want to make sure I look at the right place. So yeah. Or is it only on Zoom? Okay. So I can see the questions here. All right. That is okay. Okay, you just I suppose. All right. Well, let's give it a moment, just a bit more, to see if more folks will join. Because let's give them all a minute or so. Okay, yeah, makes sense. That's too bad. Usually these things are much more engaging when there's more people asking questions, but absolutely, hey, it's a thing. So I guess that's fine. Okay, then let's slowly kick it off. I hope you can all see my PowerPoint presentation. There should be something showing up right now. Or it's there. I don't know where my face is in relation to that, but yeah. So today's session is, I think in the official title, it was called Introduction to the AWS for Test Engineers. However, I like to call it a bit differently, right? And this is basically saying, for the love of prod, please test your code. Code testing is important. And actually, let me step back. I'll start with a story, right? Like a lot of things in life, let's start with World War II. The American Navy developed torpedoes that were supposed to be launched from airplanes, right? And they've invested a lot of money into these torpedoes, and they equipped all of their Navy with those torpedoes. However, not a lot of effort went into testing those torpedoes. So when the situation came when the torpedoes needed to be used, when the actual war broke out, American pilots, these brave souls, got on an airplane. They would fly through hail and torrents of gunfire to reach the ship, drop their torpedo, and their torpedo would just get into the water in a shallow swim, just go, reach the ship and just clunk. Nothing. That pilot maybe have lost his life. Hundreds and thousands of millions of dollars were wasted for a clunk. That's not good, right? That's not a good thing. Deploying things into production, which are not tested, is something you should definitely not try to do. So the same applies to code testing. You're a developer, you're an engineer, you're a person who maintains a DevOps type environment inside of your organization. You need to make sure that all the code that you build, that your engineers, that your developers build, is tested, right? So simple question, why test? Why should we spend money and effort and all of these things to test? Hey, Darko, it's the cloud, right? You can try things. It's fine. If it doesn't work, we'll try it again. Well, in the endless words of Amazon CTO Werner Vogels, everything fails all the time. And that's true, absolutely, even for your amazing code that you have written, right? No matter how amazing you think your code is, how amazing you think you had, I got this for sure. This will work. I've spent ages and ages making sure this is fine. It's probably not, right? So this is where you need to implement testing. You need to make sure that this will work. And how will you make sure? You will implement tests. Now, where do we test? Where is this thing where tests goes, right? Where do we start? Is it in a pipeline? Is it in production? Is it which sec? Is it the build? Is it the stage? Which part of the pipeline are we talking about when we need to introduce testing? Everywhere. Everywhere you can put the test, you should put the test. And I'll explain this in a moment, but if something is important, if you're deploying an important piece of infrastructure and you don't have a test there, you're doing it wrong. So you need to have testing in place. And let's actually talk about what is the thing you should be testing, right? What are these things that you need to start testing, right? Are these unit tests? Are these integration tests? Are these syntax checkers? Are this acceptance tests, smoke tests? All of these things. But before I kick it off, let me actually explain to you who am I and why am I yelling at you. My name is Darko. I'm Darko Mesaros. I've been working with technology for the last 15 years professionally, but much, much longer than that personally, right? I've started off with a Commodore 64 and been building up since then, right? I have a passion for making things automated, making weird things work, and also fixing problems. I also like to take that information and share it with you. I want to make sure that you do great things. I happen to work for Amazon Web Services as a developer advocate, and I'm currently based in Berlin, Germany. I'm originally from Serbia, hence the weird spelling of the name. If you want to follow more of this, make sure to check out the social medias there as well. Okay, let's start with stage number one. Stage number one of testing your code. Yes, editors and version controls are stage number one, right? From the moment you get your code away from your keyboard, since it enters the USB controller into your computer and shows up on the screen, you need to start testing it. And it's simpler than you think, right? You have all of those lovely syntax linters inside of your text editor. Now, I'm not going to get into the discussion which is the best text editor. It's of course Vim, but all of these things are kind of part of your initial testing, right? In this case, I'm actually showing you what is this WebStorm, a WebStorm with JavaScript. One of the things that WebStorm can do, along with the AWS toolkit for IDEs, is basically help you run serverless applications within your IDE, right? So this is a simple Hello World Lambda application, right? Running serverless on top of AWS. Instead of deploying it to the cloud and trying cookie things there, I can actually just run it from here, right? Have a function, run it locally, as you see, number 2, and number 3, get the output. That's all. It's all within my text editor. I didn't even have to think about the cloud. This works, right? And this is a fast way to kind of detect problems. And AWS Toolkit actually works with a bunch of things, right? For your Visual Studios, for your Eclipses, and also for all of the JetBrains things you do, right? So I think it's a valuable toolkit, especially if you're working heavily with AWS infrastructure. If you're building serverless applications on top of AWS, the AWS toolkit is just chef's kiss for a lot of stuff there. So make sure to check it out. The second part of this initial testing is your commit code repository. Yes, that's the word. your code repository, your Git, your Bitbucket, your GitHub, your GitLab, whatever you're using as a part of your code repository, that's one of the ways to kind of help you out with your code testing. Now, this is not per se automatic testing with a couple of caveats, but it's the second pair of eyes, right? So you write your code. So Jack here comes in and writes his code. And what happens there is that you spend a lot of effort and energy into it, and you're hyper focused into it over the last couple of days, and that's the only thing you see. But then your buddy comes along and just looks at it and says, why did you put a sleep function here for 2 seconds? And you may have not even noticed that. It's a simple thing, like just a simple thing. Like your pull requests are a form of code testing. Sometimes just doing a peer review on code can detect so much problems up ahead. This, what you're seeing here, this is AWS Code Commit. It's the Git solution from AWS, but this exists on most other platforms. So, any GitHub, GitLab, Bitbucket out there has a way to kind of do some approvals or pull requests. That's how Git works, right? So it's a really great way to do peer reviews of code changes, because people may catch things that you do not catch. I've actually done this with a good buddy of mine, Kobus, and him and I were doing, he was building a tool that will do some reporting for our team. And he was like super convinced that this is just going to be great. This works. This is amazing. Until he showed me the code. And he didn't just show me the code like, hey, look at the code. He started to explain the code to me. And that's actually a thing called the rubber ducky method, where you take your code and explain to other people what it does. What happens is that you actually find out problems. You find out there's like, oh, wait. I didn't want to do that. I wanted to do the other thing. So, doing version control reviews, such as in GitHub or Code Commit, is wonderful, right? It helps you find these things in the code. It helps somebody, when it looks at a code, figure out where there may be a problem. And also explaining your code to a rubber ducky or your friend. By the way, the rubber ducky method is called because usually what developers do is they take a little rubber ducky or a little toy and just explain the code to the rubber ducky, making you understand a bit more, right? So one of the things that's important, start early. It's very important to start your testing early. Start in your text editor. Add the toolkit, add SAM for the serverless applications. Have these things already built into the place you're writing code. Have linters, have little command line utilities that will do checking, syntax checking, all of those things of your code before you ever commit that code. Have a second pair of eyes or a lovely rubber ducky to help you out with your code, right? Commit your code to a repository. Make sure somebody checks it out. So use Git, use SVN, use all of those things. Pull requests are wonderful. Please don't ever commit to the main branch. You don't want to do that. Code reviews are also a wonderful thing. And if you want to take a step above just code reviews and look into a thing called Amazon Code Guru. Oh boy. So you take machine learning and you take code reviews and you smash them all together. And you have this machine learning service that kind of does code reviews. It's wonderful. It uses all the best practices that are built up throughout years of building software on top of Amazon. So if you're building something in Java or in Python, Code Guru will actually use the power of machine learning to identify potential inefficient code and potential things you can change within your application. So it's a wonderful little service that can help you with that. All right, moving on. Let's go units and beyond, right? So let's talk about unit testing and what else can we do with unit testing, or what's else beyond unit testing. And a lot of these things, once we get to unit testing and integration testing and smoke tests and acceptance tests and UI tests, this is where the code leaves your laptop. Your code has left your keyboard into the editor, has left the editor into the GitHub repo, and then it moves on from there. So it goes into a pipeline, right? And I understand that everybody watching this has at least heard of pipelines, right? Or if you have not built pipelines for yourself, they're super crucial to what you do, right? Pipelines take your code from one part to the other part and make it do something. So they're crucial. And pipelines, what we call CI/CD pipelines, or continuous integration, continuous deployment, or delivery pipelines, are the thing, right? This is how it kind of looks like abstracted. So you have your source phases where you have all of your Git commits, repositories like that. You have your build phases. This is where you compile the code if you compile code. This is where you do your unit test. This is where you do your linting, syntax checking, all of those things inside of the pipeline. Move on to testing. This is where you do more advanced testing, such as spinning up staging environments, spinning up integration tests, your unit, your load tests as well here. And finally, you have your production deployment systems, which actually get your code finally to serve your customers. But let's answer the question. What is a unit test? And this is a term that really is thrown around a lot. So, and I just want to make sure that you understand what this is, right? And according to the good book, the DevOps handbook says, unit tests. These typically test a single method, class, or function in isolation, providing assurance to the developer that their code operates as designed. So it is basically testing a single piece of code, single unit of code in isolation, making sure that code does what it should do, right? If you have a code that converts all numbers into zeros for some reason, that's a unit of code. You can test that thing by just running that unit and making sure it's outputting something. For example, in my Lambda function, this is a simple unit test for JavaScript using Jest that will basically just execute that function, right? That little unit of code that spits out the hello world, and it will make sure that it does that. If you can see on the bottom, it basically has a couple of expectations. It expects that the result will be 200, and it also expects that the output will be queries and then some JSON string. That's it, right? It's a very simple thing. It does a single thing, it tests it out, and it makes sure that works in itself. Again, it is testing, does your code do a thing, and only in isolation. So there's no invocations of external resources, dependencies, anything like that. Just a single unit of code, can it do what it needs by itself? Think of it in this way, right? Can it process the data you want, right? The way you want. It's really just self-contained. It doesn't reach out anywhere else besides itself. And yeah, does it do a thing? And how do you do unit tests on top of AWS, right? How do you actually do these things in your pipeline? A service I will be mentioning a few times today is called AWS Code Build. Now, don't let the name here fool you. It's not just for building code. It is more. It actually builds code, absolutely, yes. But it also can run arbitrary commands against your code, right? It basically has the current commit of your repository, and it can do whatever it wants against that code. In this case, I was actually running Jest tests against my JavaScript code. Simple as that, right? It can run arbitrary functions, and that's just beautiful. So unit tests sit here. If we would look in the grand scheme of your pipelines, right? This is where unit tests should be in the build phase, because they're quick and easy to run, they're quick and easy to fail, and they're quick and easy to fix. Ultimately, when you're working with test-driven development, you should write the unit tests first before you actually write any piece of code. But let's hope you do. All right, moving on from unit tests. What is the next type of testing that you kind of run into? Let's consult the big book. Integration tests, right? So according to the book, integration tests are tests where we ensure that our application correctly interacts with other production applications and services, right? As opposed for calling out just stub interfaces. So this is where you actually get to test your application against some dependencies, against some other pieces of service, just so you can make sure that it actually works with things, right? Instead of it calling itself, it will actually try to run itself against maybe a mock database, a mocked call, or something that's externally working with this thing. It doesn't have to be an actual system. It doesn't have to be an actual production database or whatnot. You can mock these things, some of these things up, but you need to make sure that all of these pieces of your application work nicely together. Another example of this one, the same application, everything is the same. The only difference here is I'm using Axios as a client. So what I'm doing here is it's kind of a quasi integration test, because I have no other element in my application besides just that hello world function. So what I'm doing here is I'm actually launching this Hello World application in a container locally. Basically, it's running as its own little thing, but I'm using the Axios HTTP client to invoke it. And then based off the output from that invocation, I determine is my test okay or not, right? So I'm not invoking the function directly with JavaScript. I'm actually invoking it with an actual HTTP client. So I'm going through a bit more of things, right? And if this was a bigger environment, if it was something much larger, of course, you would do things with some other elements of your system. But in this case, this is it, right? And this is actually, I've not got into this a bit more, but this is how it kind of works, right? So I'm actually using here SAM. I haven't introduced SAM or the serverless application model too much, but it's a lovely framework that helps you build serverless applications on top of AWS. And SAM has an ability to run your applications locally, right? The thing with serverless applications is it can get weird to try them out, right? You have to deploy them to the cloud, and then you have to invoke it in the cloud and all that stuff. Sometimes you may just want to work out of your laptop from a train or from a plane or something like that, and you may not have access to the internet. So SAM local gives you the ability to basically execute your Lambda functions locally in a container and then run your tests against it, which is also wonderful, especially if you want to do like a fast pipeline to test it in the pipeline. So code build can actually take this exact same thing, take this exact same code and execute it on code build as well. And you can see here, when we run the integration test here, we see that it's good, it has passed, voila. So what is an integration test? I like to use this example. Unit tests are, you're staying at home and playing with your toys. You're at home, you're doing your own thing, that's fine. Integration tests are going outside to play. You're going to play with the other kids in the playground. You're going to see other people's toys and you're going to interact with them, right? So how well does your code play with the rest? Can you get them different modules to work well together? You kind of test the whole application in this case. It's wonderful because you can connect to external dependencies. So if you have things that need to like an external API, that's maybe a thing you need to test it out here. You can basically validate your entire workload and create a pre-production environment from a successful unit test, right? And all of these things are running in code build. Again, code build is a wonderful tool that kind of helps you do these things, helps you run these arbitrary commands. And basically what happens here, on top of code build, which is running in a container of itself, I'm kind of launching another container that's gonna, well, run my Lambda function. So yeah, code build is it's a very, very versatile tool to help you build and do these things. There's other ways to do integration tests, right? Apache JMeter, you have Appium, you have Selenium. You can even use Lambda functions for your different types of integration tests, right? But there's a whole lot of things, and it's a very extensive way you can do integration tests. Where do these integration tests belong on a pipeline? Well, we have a whole section on the CI/CD pipeline called tests, right? And this is where they usually sit. But it's a bit more complex than that, right? At Amazon, we usually divide things into multiple different environments, into alpha, beta, gamma environments, which are all different sizes and are all in different stages of maturity. So you can see here that we have integration tests, not in alpha, no, only in beta and gamma. The gamma is like almost a pre-prod system. It's basically a system which emulates production. It has the same amount of resources. We can run load tests against this. And this is where the integration tests also sit. So it's very important to properly position your integration tests because, right, doing integration testing within the build stage or very early on may take a lot of time off of your plate, and you don't want that. So you want to make sure that integration tests are in the exact good position for these things. Here's a question for you. Do you test in production? You should, absolutely. Like, if you build your code, if your code goes through unit testing and through integration testing and through smoke tests, user acceptance tests, load tests, security, all those tests, and it goes to production, are you done? Are you done once you reach production? Remember, Remember, everything fails all the time. Yeah. So there's a lot of things you need to keep in mind when it comes to production. And you can actually, yes, you test code in production. The code testing is not done in the pipeline. You need to test your code or your application or whatever you're doing in production. And there's a couple of ways you do it. It's a thing called observability. And observability includes your metrics, your logging, and your tracing. So the word of observability actually collects these things into a single place and helps you determine, is the thing that you build good? Now, your code may work, right? Your code may be perfectly executable. It may even function fine. But is the thing you want? Is it actually doing good? If you make a code change that increases the processing time of a single call by half a second, that's fine if you have 50 users, right? But what happens if you have 5 million people using your application? That's a very big jump in latency all of a sudden, right? So it is very important to understand these things. So through tracing, through logging, and through also understanding your metrics. So these things are key in testing code in production. And how do you do it with AWS? You ask. Well, for metrics, there's Amazon CloudWatch, right? It's the be all end all service for like all of your monitoring and logging needs. It's just wonderful. All the services, all the things on AWS can actually get their metrics, get their logs, get all of those things into CloudWatch. So for your metrics and logs, CloudWatch is the place. Now you can take those logs away from CloudWatch and put them in like, I don't know, Prometheus and Grafana and whatever you want, right? You can actually take them away from that, but they can also still serve as a single funneling place for all of these things. And last but not least, when it comes to metrics, AWS X-Ray is a really wonderful service that basically integrates within your code, and you can do specific annotations and calls and all those things to understand, is there a bottleneck in your application, right? So when it comes to testing, basically it's never done, right? Even if it goes to production, even if it goes to all successful, you need to make sure that you monitor for outcomes, that you monitor for things that are good. You need to also look at metrics. You need to understand, has this impacted the way your application functions in the big scheme of things? So that's quite important, and it's never done. Again, you may think your code is fine, but your customers can do wonders with your code as well. I have a thing here that says have a rollback procedure. So when it comes to rollbacks, there's a couple of ways you can do it, right? And I don't have a slide for this, but I want to explain deployment policies. And I know this is not part of testing per se, but testing is never done. Even if you deploy things to production, you need to properly test. You need to still keep on testing. So when we talk about deployment procedures, right, you have your typical, one-off deployments. You deploy your piece of code to all of the servers, all of the Lambda functions, everywhere you want at the same time. You have your staggered deployments where you take a percentage of your code and you slowly increase the number of new out there. You have your blues and your greens where you deploy an identical environment to production with the new code. And once you are sure that the code is good, you flip the traffic to the other one. And then if something is bad, you can flip back to the other one. And also there's the canary deployment. The canary deployment is another way of deploying your code, but in this case, you actually test it in production. So what is canary deployments? What are canary deployments? Well, first of all, let's talk about the name. A long time ago, miners, right, people who used to dig for coal, would carry canary birds, little yellow birds in the cages with them in the mines. As they would go deeper and deeper into mines, they would use the bird to kind of make sure there is no methane. A methane leak can kill people if you're not careful. The thing is, as long as the bird is singing, as long as the canary is alive and singing, the methane levels are okay. If all of a sudden your little bird is silent, it's time to roll back those miners. It's not safe. It's not good. In a similar way, we do canary deployments with code. We deploy a piece of code. Well, actually, we deploy your new version of code to only a percentage of your audience. Like you deploy the new version to only 20% of your customers. And you listen and you monitor. You look at that canary. You look at that bird. Is it alive? Is it good? Are there any alarms being triggered? And if not, you just flip the entire traffic to the new version. So that's just wonderful because you're actually testing it in production. On Blue-Green, you're not testing it in production unless you deploy it to production. This thing you are, and you have like direct impact, direct sight if things go bad or not. So it's a wonderful way. So with that being said, let me actually show you how this thing looks like and how do you do your canary deployments, at least with serverless on top of AWS. So I'm going to switch my screen here to the terminal, and I have up. Oh no, wait, like that. Oh, there you go. Is this visible? For me, it somehow looks very pixelated. I'm not sure if this is for me only, but let's figure it out. So let me do it like this, that, right. So I have a simple Hello World serverless application running here, nothing special, right? If I open up this thing here, let me actually show you like that. I will move it here and such. I have a little serverless application that just, it should say hello world, or it should fail to open the page because, yeah, I need to do like that. No, not like that. Am I doing it correctly? So, okay, well, there we go. I have not tested my application code, so it doesn't work, right? So what would you do if you would end up in a situation like this, right? If you would be like with bad code, how can you prevent this, even if the code kind of works, right? So let me show you how you can do canary deployments with AWS SAM or AWS SAM through, well, a couple of lines of code. Let me show you, because infrastructure as code is important. Let me, I have it open already. Cool. Okay, so this is my SAM code. It basically creates a simple hello world function with a specific piece of code. It's just a hello world, nothing special. And it creates an API gateway. That's it. And every time I run SAM deploy, it will deploy this application. Just if I make a change in my code, let me do actually something here. app.js, if I make a hello queries here, save it, oops, that, SAM deploy. This will deploy this application directly. Everybody right now will get this application from the get-go, right? As soon as this thing is created, is deployed, everybody who wants to access my application will have the new version of my code, which is okay, but it's not the best thing, right? We may want to do something else. We may want to change it up a bit. So if I switch to the template again, and I add 3 lines of code, and these are these 3 lines of code, which I've uncommented here, right? So if I do that and do that and that and that, so what are these things here? These are deployment preferences. I'm telling SAM, hey, instead of deploying this application automatically, please deploy it by using canary deployments. And the things we have defined here is that it's going to be deploying to 10% of the audience for 10 minutes. And within those 10 minutes, it's going to listen to this alarm. And this alarm is basically just watching, is the duration of a Lambda script longer than 60 seconds? That's it. So, of course, you will have more elaborate alarms for your own use case. But in this case, this is all I need. So if I save this now, and hopefully this has been deployed, it has been deployed. If I do SAM deploy again, what's going to happen right now, it's actually going to create a bunch of other things. Instead of just directly deploying the new code to a Lambda function, it is going to create AWS Code Deploy. AWS Code Deploy is a service that deploys code. And one of the features it has is this canary deployment. So it's going to create this, as you can see here, it creates a code deploy application, and it's going to do a bunch of other things that requires for that thing to function. Once this is done, and I go back to here and go to like code deploy, if I refresh this thing here, I should be able to see, here we go. Scroll all the way down. There is this no testing serverless thing here. And you see that this application is going to this deployment group. Now, I'm not sure if it's going to have a deployment yet. There are no deployments yet because there has been no official code changes. So if I go and edit my hello world and app.js, and then let's do like hello changes, like that, save, SAM deploy. Now it's actually going to deploy this code, but it's not going to deploy directly to a Lambda function. It's going to use the code deploy service it has created to do that. So in a minute or so, we should be able to see a deployment coming up here. And once this deployment is here, in a moment, we should be able to see the canary stuff actually kicking off. Right, so it's actually creating a Lambda function, all those things, it's doing all of those things, aliases, versions, but it's creating a code deployment, right? So let's see. Refresh once again. All right, excellent. We have a code deploy. Even though it calls it the blue-green, it's not blue-green, it's actually canary. So you see here, most of the traffic is currently using the old version, the original, but the new code is only for 10%, and it's going to be listening to basically to a specific alarm, and if that alarm is triggered, it will roll back. So it's going to wait for 10 minutes until this is fine, and if there are no alarms being triggered, all of my customers, all of you, will be able to access the new version of my code. And that's how canary deployments work. And wonderful thing about that is it takes, 4 lines of code. I lied about 3. It takes 4 lines of code to implement this if you're using AWS SAM. Again, you can use this outside of AWS SAM. You can use this with other tools on AWS, like CodeDeploy, directly on EC2 instances, on containers, whatnot, but it's all possible. But through SAM, especially when working with serverless, it's just that easy. All right. Let's bring this to a close. Wrap it up. There are many more tests you can do. I've just mentioned a few. I've talked about your code repositories, your text editors, your unit tests, your integration tests, and your production testing with different deployment strategies. But there's many other ways you can do it, right? This is not the be-all, end-all solution for this. So there's a lot more things you can check out. I just didn't have time to do this in the 45 minutes we have here. And couple of final thoughts, right? Testing has different purposes in different stages, right? Your testing in your editor is not the same one as when you deploy to production. So keep that in mind. Not all of your tests need to be ultimate and complete. Some tests can be just for certain things. Testing is never done, no matter how satisfied you are with your code. Even if you push it to production and it's fine, keep on looking at it. Use the principles of observability, use metrics, use logs, use tracing to see is your application doing what you want it to do. And finally, it's much cheaper to detect broken code early, right? So I like to show this. Bad code in the source phase is very much cheaper than bad code in production. So keep that in mind. It's much easier, cheaper, and safer to fail in the Git repo than it is, well, by pushing things into production. So make sure to treat your code in that way. And finally, if you want to watch me and my good buddy Cobus here talk about testing and deployments, check out our live show on Twitch, twitch.tv/AWS, or that QR code. We did a couple of videos on these exact things, so make sure to check it out. And if not, join us every Wednesday at 1 p.m. Central European Time, where we talk about automation, testing, DevOps, and well, why are we bearded and bald? So there you go. And with that, thank you very much. I hope you enjoy this. I had a lot of fun doing this. It's a talk I like to deliver. I am very passionate about these things, and please feel free to let me know if you have any questions, if you have any feedback, comments. I am open to all of these things. And thank you for the opportunity for me to talk to you. Thank you, Andrew. If there are any questions, feel free to put them in the chat. If not, I guess this recording will be available later on to other people who have not seen it. So yeah. Okay. Thank you, Andrew. Thank you very much. Thank you, Roman. Thank you very much. And yeah, what can I say? Enjoy the rest of your day, and some future sessions. Right. Bye bye. If I cannot leave. This thing doesn't allow me to leave. Wow. Well, it seems I cannot leave Zoom. But goodbye. Can I? Wow, really? Look at this. Zoom has taken over my computer. Why? Here we go. I can. Apologies. But yeah. Goodbye.